This video is going to cover section 3.2 in college algebra, and we're going to start looking at quadratic functions. So a quadratic function is anything where the highest exponent or the degree is squared, and the standard form is written as ax squared plus bx plus c. One way to find the vertex is to complete the square. So a quadratic function is a u. It's either pointing up or down, and the vertex is that top or bottom of the u. So one way to find that from standard form is to follow these steps of completing the square. So step 1 is to divide both sides by a. So a is whatever's with the x squared. So if I divide everything by 2, I get p of x over 2, and then 2 divided by 2 is 1, 4 divided by 2 is 2, and 16 divided by 2 is 8, negative 8. Then I'm going to move c, so that's the one that's alone, to the other side. So I'm going to add 8 to both sides, and I get p of x over 2 plus 8 equals x squared plus 2x. Now I'm going to add b over 2 squared to both sides. So b is 2. b over 2 is going to be 2 over 2. 2 over 2 is 1, and 1 squared is 1. So I'm going to add 1 to both sides, which gives us p of x over 2 plus 9 equals x squared plus 2x plus 1. Now I'm going to change the right side, and that's whichever side doesn't have the p of x is really what that means. We're going to rewrite it to x plus b over 2 squared. And that means, like, if I were to factor x squared plus 2x plus 1, I would end up with this. Well, we already said b over 2 is 2 over 2, which equals 1. So I'm going to rewrite this side as x plus 1 squared. So p of x over 2 plus 9 equals x plus 1 squared. And again, I got that 1 the same place I did in the step before. And now step 5 is to get the p of x alone. So I need to subtract 9 from both sides. And then multiply everything by 2. So p of x equals 2 x plus 1 squared, and then negative 9 times 2 is negative 18. This is vertex form, meaning the opposite of what's in here, comma, whatever's at the end, is our vertex. So if we were to graph that, that would be the vertex. That's one way to find the vertex. Another way is to use the vertex formula. So first of all, hk is our vertex. Those are the letters we use. To find h directly from our standard form, we do negative b over 2a. So the opposite of b would be negative 4, and a is 2. 2 times 2 is 4. Negative 4 divided by 4 is negative 1, so that's our h. Then to get k, we just plug that in for x in our original equation. So in this equation, instead of x, I'm going to write negative 1. And if I were to type that in the calculator, I would get 2 minus 4 plus 6, and I would get 4. So our vertex is negative 1 comma 4. So those are two ways to find the vertex. Extreme values is another word for maximum or minimum values, which on a quadratic is the vertex. The calculator will also do this for us. So if in our calculator, we type y equals, and then we put our equation into y1, that will graph our quadratic. So let's do this equation right here. So y equals is this button right there. And we're going to type 2x squared plus 4x plus 6. And then if I hit graph, I should see it. If I don't see it, just hit zoom 6. Zoom is that top middle button, and 6 brings us to a 10 by 10 graph. Now, to find that bottom piece, that vertex, I'm going to hit second, which is the blue button. Then I'm going to hit trace, which is a gray button up in that top row here. And I'm going to choose minimum because we're looking for a minimum. So if we want a 0, that's our x-intercept. If we want a minimum, we choose 3. If we want a maximum, we choose 4. So in this case, I want a minimum. Then it asks me left bound, right bound, guess. So I'm going to slide the little spider using the arrows somewhere to the left of the minimum, hit enter. I'm going to slide it somewhere to the right of the minimum, hit enter. And then your calculator may ask you to guess. And then right here, it gives us that minimum value, -1,4, which is the same thing we got when we did the math. So the calculator will also give you that vertex. All right, now let's find a curve. So if I give you the vertex in a point, you can plug it into vertex form and get the equation. We can find the missing letters. So vertex form is this, x minus h squared plus k. hk is the vertex, and every other point on the line is xy. So we can just plug those numbers in and solve for a. So y is 69. We don't know a. X is 8. H is 2, so we'd put -2. And then k is -3. And now we're just going to do the math out to solve for a, do the algebra. So I'm going to add 3 to both sides. And my parentheses is 8 minus 2, which is 6. Then I'm going to do 6 squared and get 36. And to get the a alone, I divide both sides by 36, and I get that a equals 2. So for vertex form, I would just put the x and y back in and plug in the 2 I got for a, and then my vertex from over here, 2, -3. That's vertex form right there in the purple. Now, let's say I want standard form, depending on the directions. I, again, just do that math out. So I'm going to FOIL, which squared means I have 2 of these parentheses. So I'm going to FOIL those. First times first, outside times outside, inside times inside, last times last. Bring down the parts I didn't use. Now I'm going to distribute that 2 to everything in the parentheses. So I get 2x squared minus 4x plus 8. Bring down the 3 I didn't use. And then just combine like terms. So -4x minus 4x is -8x, and 8 minus 3 is 5. So now we have vertex form and standard form. All right, quadratics are real life. Gravity always follows a quadratic equation. So if we're talking about projectile motion, so this is motion, throwing a ball, anything, shooting out of a barrel, anything like that, you're going to use this equation. V sub 0 is the initial velocity. That's the starting velocity. And S sub 0 is our starting height. Why they use S, I don't know. So we just plug those in from the information given and go from there. So let's start. A ball thrown directly upward from an initial height of 100. That's telling us that SO is 100 and an initial velocity of 80. So that's telling us VO is 80. So we plug those into our equation. The -16 is our gravity. It's the force of gravity. That's why it's always 16. Plug in 80 and 100, and now we have our equation. Graph that. I'm not graphing this by myself, so I'm just going to type it right in my calculator. I'm going to turn these off. There we go. So I'm putting -16, and instead of t, just put x, because that's our only option, plus 80x plus 100. If I hit graph, I don't really see it, so I'm going to zoom out again, and we can see that it's really thin, so I'm just going to change my window. Let's try a window of -10 to 10, and hit graph and see what happens. So now we can see it. We still need to go taller. So I'm going to change my Y max to 300 and see what happens. Now I can see the whole curve. So there's my graph. Your window can be whatever you want it to be. As long as you can see the intercepts and the vertex, you're good. What does the point 4.8, 115.36 mean on the curve? Well, t is time, which in this case we're using for x. So at 4.8 seconds, because these are in seconds, and then this is our y, which over here is our height. So the ball is 115.36 feet high. That's all that point means, is at this point in time, here's where the ball falls. So at 4.8, which is like here, the ball's 100 and something high. Good. Water when is the maximum. So maximum is asking for the vertex. So I'm going to hit second trace and choose 4 for maximum. Left, enter, right, enter, hit the guess. Now it's telling me my max is 2.5, 200. So that means at 2.5 seconds, the ball was 200 feet high, and that's the highest. When will the height be greater than 160? So there's a couple ways we can do this. We can solve the math where we're saying, hey, here's our equation, negative 16t squared plus 80t plus 100 is greater than 160. And then subtract 60 from both sides, or subtract 160 so that it equals 0. So we get negative 16t squared plus 80t minus 60 is greater than 0. Plug that into y1. Minus 60. And then we find our x-intercepts, because it's from here to here is when it's greater than 0. So I would do second trace 0 this time. And then I go to the left of one of the x-intercepts, the right of the other x-intercept, and it gives me this 0.91, 0.92. And then if I did it again, second trace 0, and then I do the left of this intercept, the right of that intercept, and this one tells me it's at 4.08. So between those two, from 0.92 to 4.08 is when we're greater than 0. We also could do the same thing with our original equation, 100, and then draw a line at 160 and find where those intersect. Second trace intersect, number 5, that'll give us that same information. All right, lastly, when will the ball hit the ground? So that's asking us when x equals 0. So for our regular or initial equation up here with the 100, we would find the x-intercepts. So we're going to do second trace 2 for the x-intercepts, and then do our left and right from the original x-intercepts, and it tells us we have negative 1.04. So if we went back in time, it'd be negative, which we can't do, so we can ignore that one. And then we do the left and the right of that, and we get 6.04. So at 6.04 seconds, the ball comes back down and hits the ground again. So that was a bunch with the calculator and some quick reviews or lessons about finding the vertex. Let me know if you have any questions.